I think we're live. Yep. Let's wait a bit for everyone to come. I think today we should have a bit more people than usual. Should be nice. Hey everyone. I think some people joined us. Welcome. We're just waiting a few minutes for everyone to kind of come in. And then we'll start. We have a bunch of things to do. Maybe not all of them today, probably not. Yeah, and kind of like to introduce the topic, the project that we are doing here. After the discussion of last 2 days on Reddit. There seems to be a good amount of interest on this, and that's really exciting. So it's a popular language, and I expect some people would really like to see something done with it, like in the game engine world. Okay, I think we should start in a couple minutes. We'll do some UI today. I hope we can have something like this going on. That would be exciting. ImGUI takes a bit of work to set up, but it's amazing. And yeah, that's the original C++ project. Maybe I'll share these links with you guys. Okay, latest version. Waiting, let's install ImGUI Go. Let's get it as a package. I think all we have to do is just go get this. Nice. 1.12. Isn't that old? That's weird. Let's see examples, go mod. Oh, okay, it's V4. Let's get V4. There we go. All right, I think it's good. Good enough. Now we can start working on this. So again, welcome everyone. I think we will be having a bunch of new people joining us, and I wanted to introduce kind of the project that we're building. So the idea is we would like to build a game engine, full-blown 3D game engine with physics and so on, as much as we can do in Golang from scratch, as much as possible, as much as you can do in a lifetime from scratch. But we'll hopefully stay away, if we can, at least in the long term, from libraries, and we'll tend to implement things on our own. So no super high-level libraries, except maybe, for example, physics. Like, sure, we'll use something like physics and from NVIDIA to have some really good physics, but aside from that, I think we'll tend to build it in the game engine, and we'll try to make the game engine actually performant, right? And I think this is doable in Go. There was a lot of discussion saying, maybe it's not possible, or Go just isn't good enough. And on one end, like, yes, it's not as easy to build super high performance code like this in Golang, but at the same time, I think Golang is even more suited than things like Java or C# for this kind of task. And yet, especially C# still remains a lot more popular in this regard. And so it's a journey. We're going to see, I guess, how far we can get this. But I believe we can get something really good. Maybe not building Call of Duty or Battlefield, but definitely something good, right? And so we'll be streaming here every week, trying to get this off the ground, and we'll see what we do on YouTube. Maybe we'll have kind of like shorter clips of what we do here. We'll see about that, right? And this is the repo, if anyone wants to come in. It's Blois/nMage. That's what we're calling it right now. nMage, I think it's kind of cool. That's from the original title of the stream, which is Noob Making a game engine. So let's do it. So for today, we have a few to-dos that I had in mind. Maybe not all today, but I would like to get a resizable window going. Have a full ImGUI integration. At least we can have actual UI on the screen, and we can drag things around and receive the output and so on. So hopefully we'll have that going. And then it would be very cool if we actually had a moving camera. So a proper camera system as well, right? Maybe we do the moving camera first before anything else, right? And then we can talk about a bit of what I'm doing for asset loading, and if people are interested, we can even do this live, if possible. And yeah, the buffers package I really don't like. It's not fit, and I think we'll do ImGUI first, and then we'll see that, okay, it's not good enough yet for us to do things like ImGUI, right? Then this is potentially later on, but yeah, this kind of maybe combines with the rework is how do we want to set up our memory, because I don't think it makes sense for us to keep doing different buffers on the VRAM for each, like if I want position and a color and so on, and we're creating buffers for everything, but then they're all part of the same vertex. So why don't we just have one huge buffer and put everything there, right? So that could be one thing, honestly. So yeah, but we'll keep the discussion for this bit later. Now let's start with the resizable window. So if we run nMage now. What did I do? Did I do something? Oh yeah, because I updated right, let's go in these boys out. Oh no, I'll just have the no this one as well, because I updated the math library, and that's actually something another thing we should talk about. So let's try to run again. One of the interesting things I found out is, and this would be interesting for us, is that there isn't much in the Go ecosystem for games, like at all. There's barely anything going on. There isn't like if you want to do physics, there isn't really like a nice 3D physics, a popular binding like for physics, for example. You want to load assets, you want a library that can load a bunch of assets. It's not there, and so on. And even math library, like yes, there are, but not kind of what I wanted, but still less popular, and so on. So wherever I go, and then probably for sound, God knows what we'll find in the sound side, but there really isn't much. It's very clear that there hasn't been much development. Like I already see Rust, which is much more recent and lacking in other libraries. They're already ahead in kind of having the ecosystem built up. Now, while this might sound bad, I think it's actually interesting for us because, hey, we can build these things ourselves. And so I already started. We have our nice math library. I'm working on, might show it off later, on asset importer. So I'm kind of creating bindings for one of the best asset import libraries I could find, originally in C++. But then asset importing, it's usually done offline, like we do it when you are using the editor and not when the game is live. And so we don't care that much about performance. So we can potentially go with something automated bindings to some extent without optimizing it a lot, and that's just locking. Okay, anyway, let's get these. So let's look at our shaders here, because we got a black screen. Models, shaders, or vertex shader. we were just applying the model matrix, so we don't have any other matrix yet. We're applying the model matrix here, and we're loading kind of a 3D object into the scene. Now, this 3D object, we're multiplying everything. Okay, so let's not transform. For now, let's just do the model matrix and then apply that. Oh, we need to load it. So let's just do it. Let's fix this. So this thing is simply 0, 0. And so what I did in the math library compared to before is it's column major now. So we don't need to transpose when sending to OpenGL. And that just means that in memory, the object, so if we have kind of, a matrix like this, 1, 0, 1, 1, right? We have a 2 by 2 matrix like this. In memory, it's all actually just a straight array. It's all a flat array. And the way we put them in memory defines whether it's row major or column major in memory. It's separate actually from the math one. Maybe I'll do a video just on this because it's a bit confusing. But in memory, we can either put the row, this row first and then this row. So we end up having kind of this in memory. Okay, one element, then the next element, and then 1, 0, and then 1, 1. So we put row by row after each other. Or we can put columns first. So we put 0, 0, then 1, 0, and then 0, 1, and then 1, 1. So we kind of go up, down. We take this, and then this, and so on. So we put column by column. Math, interestingly, is done usually. Yeah, that's a bit different, but we usually use like column vectors, and then in the array, on the computer side, OpenGL expects column major, not row major. And so if you're sending a row major, you need to transpose. And since we're focusing on this, like, and it wouldn't matter too much because all APIs, like even DirectX and OpenGL, they can deal with both. But in this case, just to be a bit more native, it's column major. And so it's column major, and then this thing represents the first column, is the first index, and then the second one is represents the row. So column 0 and then row 0. Then we can update these, the same thing. So we can say we're not transposing, and we are sending first row, first column. Again, same thing. We're not transposing, and yes, the vector should be the same. And that's all the changes we need on the math end. All right, let's run again. Now, come on. We should see our shape on screen again. And then we should we can do the other matrices. And then we move the camera with the input system we made, and we'll have kind of the start of an editor that we can actually use. The compilation time is sad here. For some reason only in the beginning, and then it comes faster. Okay, so we're kind of very zoomed in, very close, but we can see kind of the edge of the shape because it's kind of a ramp, I guess. That's the one we have. So it's okay. Let's now apply the other matrices. Where is this? So we have a model matrix. It's apply translation, scale, and rotation. Right. So let's see. So translation, let's center it for now. And then we'll make it smaller because it's kind of huge. So we'll say, hey, it's 0.25 of the original size. So it's only 25% as big. Okay, and 0, 0, 0, no rotation at all. And then we multiply these. So we multiply the scale with the rotation. So it's kind of like we apply scaling, and then we apply rotation, and only at the end do we apply translation. The order here is important, otherwise you might get really weird results. And then at the end, we set the uniform. So let's look into that. Come on, go, you can do it. Yeah, so now this, I assume, would give us kind of something that's centered in the screen. Are we going to get it or not? Come on. And then we can talk about projection matrices. Oh, there we go. Nice. So our, I think we were seeing only essentially the left side. We were very zoomed in because the object, I think, is huge. And so we applied scaling to it, 1.5. And now we can start playing with these. And as we move them around, this thing is going to shift. So movement in the game world, like let's say moving the camera. So if I move my camera to the right, all the objects shift to the left. Right. Essentially, the camera never moves. It's just that everything else is multiplied by a matrix that moves it in the opposite direction, and that is movement. Right. So in a way, the camera doesn't move; the world moves, as you know, they say in graphics, because every single object in the game will be multiplied at runtime by the on the GPU by this transformation matrix, which is made up of all these three matrices, right? Made up of scaling, rotation, and translation, all in one matrix. We multiply and we kind of shift the object in the way that we want. I think if we, for example, do a 90-degree rotation here and run it, we should see it rotated, I think, like this. It should with 90 degree. But we don't have depth yet. The object getting bigger and so on. But as you go further back, kind of the perspective effect of the object shrinking and objects closer by appearing bigger is not there. So what we have to do is Rejection Matrix. We need to have something like this, and this represents the camera. And if you have used Unity or anything similar, yeah, this is very weird. I think to get fixed once we have proper camera attributes. Okay, so when we have camera like this, it's a good image. The kind of the box in the middle. So if the camera is where they say, it's I at Z0, is looking downwards, then the camera is going to see within this box, right? And things further away should appear smaller. But then between these two, like dark blue boxes, the far plane and the near plane, this is the only place we actually see. So things too close to the camera we don't see, and things too far we don't see. So they kind of disappear. We only show things within this box, right? So we need to define, and this is yet another matrix essentially. We have moved by multiplying by the model matrix. We have moved from the object space where the vertices are all, let's say, from 0 to 1 or something like that in the modeling in Blender. We moved it into a world where we can put them next to each other. I can say, hey, this is at position 1, this is at position 10. They'll be kind of next to each other. And now we need to multiply them again to put them in the view of the camera and to have this projection, so that we only show the things that are within that view. Anything else disappears, essentially. It is again by multiplying it. So we have what we need. We need a few more matrices. So we have our model matrix, and you heard the word MVP matrix. That's model, model view projection matrices. Right. So we need a few more uniforms. They're all mat force, and then we'll do a view matrix and rejection matrix, and then in the end we can multiply all of those, right, to produce the MVP matrix like this. Okay. So how do we make these? So in DGLM, I already made some of these. So here we have our model matrix, which we're sitting here. Okay, let's create a view matrix. New. Don't actually remember the view matrix. Let's get an identity. Oops. New mat for identity, and let's get projection matrix. Right. In projection matrix, it's two types usually. You can either have this thing where things get further smaller as they go further away, or you can actually have an orthographic camera. And orthographic matrix. Orthographic, there is no depth. Like things don't get smaller as they go back, like this. Things are all the same size. They kind of look weird, and this is a nice image, I think. It's all white backgrounds, but the difference is one thing. This is the normal projection matrix where it kind of is smaller in the beginning and then larger at the back, but then the other matrix is like a box. The far clip and the near clip, the places where we see in between, it's a box. It's the same size throughout. It doesn't get bigger or smaller, right? And this gives you kind of things that are, no matter how far back they are all the same size. They don't squish or like look from angles or so on, which you might use for a 2D game, for example, or maybe UI, not sure. But yeah, it has some uses. Not as popular as perspective. So for us, we want perspective camera, so we can run the perspective function. Then you get the FOV, which you see common in games, right? Just put something 70. Aspect ratio. So for us, let's divide the window height, window width by window height, and let's see, near clip. So how close to the camera and we still see things. So usually this is very small, so like 0.1, let's say meters away from the camera, you still see it, but anything closer, we don't see anything. And then the far clip is, let's say, 10, like 10 meters back. So this is a perspective matrix. View matrix, do we not have? I completely forgot the view. Let's see. New rotation, scale. Okay. We can go into this, but let's apply this one. Our projection to we call it projection max, right? We are going to send this. We need okay. Let's cast this to a mat 4. GLM mat 4. What's wrong? Um, 2 mat 4. Well, come on. Discuss it. Okay. The data. Actually, that's enough. Yes. Let's get. Can I take address? We should expose this. Honestly, this is not exposed. That's weird. Look at GGR. This is not. It's not supposed to be a math stream, but let's look into this. So translation matrix is nothing more than it contains a mat 4. Yeah. And then this matrix just is translation matrix. So we should be able to get mat 4 directly out of it. Okay. That's odd. Should be embedded. We can just send the data, but that's really weird. Yeah, this one's a mat 4, and then this is the same type. Yeah, this embeds a mat 4. Okay, let's get the value and cast to mat 4. What does this give us? There we go. We got a mat 4. Then, all right. We can fix this data, but it's okay for now. This is good. All right. So we are sending now our projection matrix, and we're multiplying it to apply it. Let's not put the view matrix just yet. We'll see how to put that in a minute. Let's run. I would like to, once this is working fine, we can then have a small camera controller, which when we press the buttons, we essentially just move. We translate the transformation matrix and update the uniforms. And this will give us the effect of moving. And while this is doing it, let's look at transformations. They have a really good article on all the different matrices. You can see there's a bit of matrix math. It's not that hard. the concepts are kind of nice, actually. Translation. Let's see. So what do we have? Okay. So what we want is the view matrix, not this. Let's search for view matrix. I think I did this somewhere. Rotation. Oh, okay. The look at, yes. Look at. So let's do that. Look at. So we need this, and then we can actually keep the view matrix. So model view matrix. You kind of read it from here. So we're using column major. You multiply these two first. So you apply the model matrix, and then you apply the view matrix, and then finally you apply the projection matrix. That should give us the final look of the object on the screen. Now the position. So look at gives us the view matrix by taking it essentially transforms. So here's the thing. This gives us movement, scale, and rotation. Right? That's the model matrix. The view matrix moves objects into the camera's view, right? Or sometimes like you could call it in the camera space. So you actually put it like, hey, is it in front of the camera? Is it outside? If it's outside, we don't see it. So it's kind of shifted in that way. And then finally, the perspective gives us perspective essentially, which is depth, right? Depth. Things further looking smaller and so on. So now for the camera, for the view, we need a position. So where is our camera? And we'll take, it's a look at. So our position, and then what is the thing we're looking at, right? So like a point for where we are, a point which we want to look at, and then the y-axis of the world. So that would be like a vector pointing out. So our position. So let's say, where do we want to keep our camera, right? So let's say camera pods. Let's get vector 2, right? And let's say we're located, it's a vector 3. I think there are some nicer helper functions now. Vec 3, new vec 3, okay. So let's say the camera is located right in the center, 0, 0, 0. Right? Maybe, so if the object is at 0, 0, 0, maybe let's put the camera back. Yeah, it's because our object is at 0. So let's put the camera kind of back on the z-axis 10. I think in a right-handed coordinate system, the z-axis pointing outside the screen, like in OpenGL is outside. So let's move it outside. Shouldn't matter either way for this, but we need our camera position, so send that. We need target position. So target position is 0, 0, 0. Right? That's our translation matrix here. So we're looking to the center of the kind of the world, okay? And then world up is nothing more than the y-axis in our case. That's the world up. Now that we have these, we can simply we can send the view matrix. We can say, hey, there you go, take the view matrix. Oh, hey, you got mat4. What is happening with this? Oh, wait, perspective already gives us mat4. Oh, wow. That was stupid. Set that. Yeah, there you go. Okay, so I was applying the wrong thing. But, all right, so we need UMAT. That's that. That should be it. Are we multiplying everything? Yes. Let's see. I'm not sure about this perspective. What is this? The aspect ratio. I think yeah, it's width by height. Or is it between the near and far clip? Not sure. Let's look at the camera. So right axis, yeah, that's the lookat matrix essentially. It went out of view. Okay. Let's do perspective. Where is the perspective? Is it here? Perspective. Not here. Coordinate systems. There we go. So these are the transformations we kind of do from being the object space to the world space, and then looking from the camera's perspective, which is a view matrix, and then giving it depth, which is the perspective matrix. So let's look at perspective. Graphic. Yeah, there we go. This is similar to what we have. Oh, we need to pass this radians, do we? All right, this is already handled. Yeah, FOV should be handled internally. Then aspect ratio is width by height. Okay, 45 degrees, and maybe this should be radians. Let's see if we, in our math, are we handling this? Yeah, I think we should change it to radians. So let's multiply this by degrees to radians. We should have actually a comment saying that this should be radians. Okay. Let's run, and then this should be okay. And this is essentially your FOV slider in games. It's just changing this value in the matrix, putting a new matrix. But with this, we should be good to go. I have no idea why it's so slow today. We didn't really add any. Oh, we do have ImGUI, but that shouldn't be so bad. Okay. Nope, it's still too much for it. Perspective matrix, projection, view mat, and model mat. So model, view, projection, and let's confirm code. Yeah, it's correct. Okay. Let's see. That's our camera at 10. And target position, 3 radians, view matrix. Yeah. Okay, this is okay. Okay. Let's remove any rotation for now, and let's maybe decrease this. Let's use 45 like we are doing. What is width? I think, yeah, it is width by height. Aspect ratio, the viewport's width by its height. So our viewport is just our screen. Yeah. And let's see. Just print what our view aspect ratio is as well. While it runs, there is this annoying print we're doing. It's huge array. That's the thing. But printing indices we load from the obj file if you don't know. Okay. Right, so well, this loads. The next step would be for us to handle the game logic. Yeah, I think we can put it there. This is where it would be nice to start having kind of the idea of objects. Oh, and we cannot resize the screen. Let's do this, and then we can resize. Resizing should be easy. Okay, so these things we know work well. Just the model matrix. And then the view matrix is 10 on the Z. Our target is at 0. And camera and targets. This thing. Wait, our aspect ratio is 1? What? That's wrong. Oh, should we? Let's convert to float. Is that it? That is wrong. Absolutely wrong. Make sure we convert this as well. Float 32. Okay. Could be just we're doing integer division, and so it was completely, yeah. So our width is 1280 by 1720. All right. Now to start thinking about our matrix, sorry, our camera movement, what we need to do is we need to start using our input library. Be nice. And then movement for us is we have to, I think there are multiple ways we could do it. Now, wow, this is still completely dark. But yeah, we have some norm. 1.7 is our aspect ratio. It's fine. It doesn't seem like an issue. Maybe let's try again without it being radians. Because there is no note on it needing radians, is there? Aspect ratio. It does actually need radians. Because these math libraries usually only accept radians. Yeah, of the radian argument. Yeah, so this must be, FOV must be radians. We should comment this. And then the arc. Sorry, we're doing, yeah. And then near clip and far clip. Oh, right. I think we're just at the edge. Yeah, we won't see anything like this. So one thing. So I think this is a problem. Let's put this at 20. Let's put the far clip at 20. So we put the distance. So this thing we pass, right? How close is an object to us and we still see it, and how far is it, and then we still see it. And this was at 10. So an object at 10 is the limit, but our object, our camera, was 10 meters away from the target. That is exactly at the limit. And so probably what was happening is the object was getting cut out of the screen. So it was being clipped. This is why they we call the near clip and the far clip. So what are the places where we actually clip the thing? And so, yeah, I think this is Oh, there we go. Amazing. We can actually feel it. Like we're so far away. It's not. We scaled it to 25% of the original size, but it was still much bigger than this. But what's happening is our camera is so far away that the object is appearing smaller. Now let's do some nice inputs. What we want to do is we can either move the target and update the view matrix every frame, or we can move the camera. So let's say we're moving the camera. Let's imagine we have some camera control, right? We're moving the player, and so we can kind of move the camera and kind of get closer and further and so on. So let's take this thing out. So actually, yeah, let's take these two. Let's put them here. So that's our camera. Let's let maybe, let's say our starting camera position, and then the target position is always 0 in this case. And then every frame. So perspective, we're not changing. This thing we're not changing, so we just need to update this every frame. Right. So handle inputs. So this, we're finally rewriting some game logic, and this is so exciting. It's cool to feel that you're making progress, right? And we're definitely doing a lot of that. Okay. So you have position. So what we want to do, let's do this. So if we have our input package, if key down, while the key is down, and the key code is is it K? Yeah. Okay. If let's say if the W key is up, is pressed, KW. So we want to move ahead, and moving ahead is reducing the camera Z position, right? So we can say camera position dot Z or yeah dot set Z. Let's set dot Z is whatever the current Z position, right? Minus, let's say minus 0.1. I hope this is not too fast, but yeah. We also need to work on timing soon. Let's just add a to do timing and delta time to make it frame independent. But anyway, okay. So if we press forward, we want to get closer to the 0 axis. We just, yeah, I mean, what would make sense is that this is kind of flipped, but then this is the way visual works. Anyway, let's do this for now. Then if we have S clicked, right, let's add, oh, this is not X position, Z position. Right. And then we want to move also left and right. So we say if D is pressed, we want to move right, and so we're going to set the X position. We're going to set that as, you know, X. Yeah, so moving to the right is just adding to the X, and moving to the left is subtracting from the X. And then we create our new view matrix, and we set that. I see. 0.1 could be too much, maybe. I don't know. Go to run and see. Okay. So one thing is, if we run fast, if we're doing, let's say 100 frames a second, this is going to run 100 times. So we are going to move faster, right? We are going to decrease this rate faster. If you're running at a slow frame rate, then your movement speed also slows down. And that's why, you know, we have this delta time thing. Okay, let's try this. Oh, there we go. This is perspective. Ladies and gentlemen, it says perspective. This is so cool. Right, and then I'm rotating. I shouldn't be rotating. I should just be moving left and right. Or because we're moving the camera. Yeah, this kind of makes sense. Because the camera is going like this, and then we have a look at matrix, so it's kind of turning to the side. It's not just, we're not just moving the camera, we're actually rotating the view matrix. So you can see it's like it's curving to one side, and then we can also move multiple directions all at once. Right? This is really cool. And a bit confusing. Yeah, this is definitely confusing, but we have something. Yeah, it's a start. It's really nice. The other thing we can do is which I think what's usually done is we use the we change the model matrix, not the view matrix. So your camera is there, and then we can also keep the camera looking straight ahead. So the camera is there looking at 0, 0, but you can move the object. So we won't do it like this. I think we can move this up, and we can put it here. Right, so we have our position. So we'll always have the camera looking at the center of the screen. Let's do that. Right, at least for now. Play with this, which is very cool. We'll always have the camera looking at the center of the screen, but what we'll be moving, what we'll be changing is this translation matrix. So let's move this. Let's have our model matrix up here, right? And then we apply some initial stuff just to create it the first time, and then we set this. But then what we do in our game logic, we do something. So we set the model matrix instead, and if we press the W key, what I want to do is the model matrix. So we have some nice functions on that, on the transformation matrix, like translation. So we can tell it, hey, whatever the current position is, move it by X amount, translate it by this on with a vector. And so in our case, it's forward. And so again, let's do this increase by 0.1 on the X, on the Z, sorry. And then in this case, back is to go minus. And then let's see, for the moving right is 0.1 on the x-axis. And then again, 0.1 minus 0.1 on the x, and that's moving to the left. And then we update the matrix. So whenever you move an object in 3D space, we have to update some of these matrices, right? Some of them you might notice can be common, and there are ways to help with that. So every single object in our game is not going to have the same model matrix, but it's going to have potentially the same view and projection matrices, right? So even though they all share the same matrix, we're sending this uniform to all of them. So there are ways of kind of having shared uniforms between all the shaders. All right, let's try. Okay, going back, forward, left, right. Okay, now this is proper left and right? We're not rotating to point at it because the camera is just always looking straight ahead. We just, we do that. It's so cool. You can almost, almost build a game with this. And you can see the, it's 3D, sorry, this might have been loud. The 3D effects of the object. You can see it's an actual 3D object that we can move around. It's all reversed. It's all these controls are actually reversed, which is weird. But yeah, it's a right-handed coordinate system. So Z is, yeah, going forward. We can flip things, but this is okay. Let's just flip this one now. And we can worry about this later. Okay. So cool. So we actually have some nice moving camera. Right. This is done. Resizable window, still have to do, but moving camera, all the magical projection matrices and so on, this is all done. And that's why we have this super cool moving object, which if it ever loads today, this is done. Now we would like to do our resizable window and then start looking at ImGUI, which is something we need. So again, yep, now okay, left and right I didn't need to flip, just the z-axis, which makes sense. So we have this, you can see the 3D, we can even have multiple objects, but I leave that for when we have some entity system in place to actually easily spawn things. You can see when we get closer than a certain point, it disappears. This is the near clip, we're passing the near clip here. And if I go far enough, it's going to suddenly disappear. See, even though it didn't shrink to 0, but we have gone far enough that we crossed. This is like 20 meters, and now this is our far clip lane. That's it, we crossed it. So this is what the far clip and near clip, these two parameters mean. This is how close we can be and how far we can be from it, right? This is our FOV slide essentially. Let's get rid of this. Let's work on resizing. Resizing is actually easy. We need to do two things. We need to tell OpenGL that, hey, the window is actually resizable, because otherwise we won't even have the mouse cursor up here. So we'll do SDL dot window resizable. Right. So our option, which still won't work, because if you remember, we always have to do something with inputs, just handle events. So let's do that here. So if it's a window event, we are, hey everyone, I have some more people on the stream, nice. If we have some window event, then we can check, is this event, I think the type, is it an SDL window event, let's see, resized? If it's not, so we can say, hey, whatever else, like we don't care, we can continue, right? Go to the next event. Otherwise, what do we want to do? We want to, so we have the window object, we want to set size, we want to set the width and the height. And if we look into the event, we have data 1 and data 2, and if you read the docs, it actually turns out that data 1 is where the width is sent, and then e.data 2 is the height. So these are our new width and height of the screen. And I think we also need to change the GL viewport, which we are basically telling OpenGL like, hey, this is, you know, how big our screen, this is how many pixels we have, the viewport. Let's try with this. Let's try without the viewport for now. And we should also, now this breaks our view matrix, right? Because now our aspect ratio is all wrong. So I think let's have, our projection matrix. So the very top, let's have, again, projection matrix. Let's have a new map for identity. And we can recalculate this every time we have resize. So this is our thing. Now I should be able to, yep, so drag and I leave it, it updates. This looks fine, I think. Now we have more. Yeah, there you go. This is why we need to do the viewport. So the window did resize, but you see how there is like it's as if the window is still there. This is because, and vertically it will be the same, but this is why we need to update OpenGL. We tell OpenGL, hell, actually we have this much space, right? Our window changed. And what this thing is called is, well, it could also be the projection matrix, but that's also the viewport. So let's fix one thing at a time. Let's fix the projection matrix. Mat4. All right. Let's create the matrix 4. And then every time, so we'll initialize this. We should make this as variables now. Okay, and then what we can do is update. So the window width now changes to e.data1. Window height e.data2, and then we set those. Width. We said width height, and then in this case we should also update the projection matrix. So where is our projection matrix code? There we go. And then we said that. So our projection matrix is this. It's all the same, except I'm going to change. Yeah, we're just setting these. We're calling it again just to set these values essentially. And then we need to set the uniform. Right. So simple shader that sets uniform at 4. And this is our projection matrix, and this is our value. So let's see how this goes. What's wrong? Int32, sure, let's do this as int32. We won't have a screen bigger than that. Okay, then int32, int32. What are these? Oh, they are already entered. All right. Ooh, fine. I wonder if that will still happen. I'm not sure. I think so. I think we need to set the viewport as well. Yeah. Oh, and we don't need to invert left and right. Only the z-axis is pointing out. So left is minus on the x, right is plus on y. This is because it's a right-handed coordinate system, and so if you use your right hand and you do this thing probably taught in school. So if this is our x and this is our y, our z points them back outside the screen. So to increase in the z, we have to, or to move back from 0, to increase away from 0, we have to what do you call it? To move away. In this case, at least, we have to decrease, or to move closer to 0, we have to decrease z. All right. So again, left. Wait. Why is this wait? D. Yeah. Oh yeah. This is correct. So when I press right, the object moves to the right because we're moving the object in the camera, and then left, object moves to the left, and then moves closer to us or further away. Perfect. Now, so here it's going all the way to the end of the screen before getting clipped. Let's resize. Same thing. It's as if the window is still there, right? So this is the GL viewport. GL doesn't know that this happened at all. So if I put this here, then it makes sense. Otherwise not. So what we'll also do, one more GL call is, where is this? Here. When we set the window, we also tell GL like, hey, GL viewport still 0, 0, top left. But then width is our new width. Height is the new height. And then this should work. So with this, I think resizing windows. Right, this is done. Then we can start looking at ImGUI. We really need ImGUI, I think. We need controls. If we build an editor, we need that. And if we just want debug info, we want to see some values change in real time. Maybe I want to see the position or my matrix being displayed every frame, so on. So we want to have some debug info. We cannot live without ImGUI, but it does take a bit of setup. So we'll see. Okay, let's get closer. And so we go, let's see, let's go here, for example. Okay, that's good. Now if I resize, oh, this is still happening. That's so odd. Did we save? Yeah, we did. Yeah, it's still happening. I'm not sure if it's no, the camera should resize. Yeah, this is correct. So the left side is good. The right side is all wrong. Interesting. I mean, we can look into this. Real viewport is the new width and height. Width height. Yeah. So what's the issue? Okay, let's see. STL resize window. Okay, it's okay. Okay, this is just, I think it's different. It's really old. This is not critical, so probably we can leave it for later, but let's see. Yeah. We are updating our projection matrix. Okay, we have this. We have this, and we built. Doesn't seem like there's anything fundamentally wrong, at least. But we're getting the new stuff. We have the window. Let's see. And we are updating the perspective matrix. Yep, this is correct. Every frame we do this. If we get this, we yeah. We said that. Well, data, win width, win height, win width, win height, geo viewports. I'm not sure actually. This looks good. This looks good. Model and view and projection. 45 degree to add. Yeah, it's okay. I think we can leave this for now. I'm not sure if it's better that we do this every frame, maybe. But I think this is good. Good to say. Can stop realizing for now. Okay, ImGUI. So ImGUI, we're looking at the beginning, the stream. It's this library that doesn't. It really works on a low level where it doesn't care much what you're using to render. Is it DirectX? Is it Falcon? Are you doing something crazy? It's not a high level GUI library. It's a very low level one. So all it gives you is like, here are the vertices. Like just like we're doing, it gives you essentially the buffers. Like here are my vertices. Go crazy, draw them. And it follows the immediate mode UI philosophy. And immediate mode is essentially we don't create objects that persist across frames. We don't like we did with our box. Like we make the box and we put it, and then okay, the box remains there in the game even if we don't do anything. That's not the case here. Here you call some function. As long as you called every frame, that button exists for that frame. But if you don't call this function, that button goes away. Right, so it's immediate mode. Like on that immediate second, if you do it, you get that. Otherwise, it goes away. And this is one of the most popular libraries for this. You can see there's 2,000 stars and 6,600 commits. It's huge. So luckily, this is all in C++. But luckily, someone made this in Go. They have some Go bindings. And this is the examples. This is what we'll follow to integrate, because integration takes a bit of work to set up the first time. So let's see. Let's go into command. Yeah, let's go into command. So we're using SDL OpenGL3. Yep. Let's look at this. Here's where they're running, and they're using the internal package. They have a renderer and a platform. We don't have these abstractions yet. We'll probably get to them. Let's go into internal and see example and .com. Yeah, we should follow this. I think. Suppose ImGUI. Let's keep only this one. I think that's enough. And then even this we don't need. Let's keep only the examples. So they say that. All right. So we have internal common example code. All right. So let's follow this example code and see how we're going to integrate this into our own engine. So in here, it's just kind of using these libraries. It's creating an ImGUI context at the very start. Makes sense. Then that's the SDL window. We have that. They create a new render, which is their own abstraction over OpenGL, and then they run. Okay. So this is not that useful. Let's go to this thing, the example. Okay. So platform to them is just kind of an abstraction, a bunch of functions. Let's see. Renderer is just pre-render and the render function, and it takes a bunch of things, right, including ImGUI draw data, which I think is what we need. And then that's the run. Right, that's the main program loop of the demo. Right. Okay, let's just set up process events, and P is the platform, I assume. Okay, so let's not worry about events now. All we want is to integrate this with our window and buffers and whatnot. So we just want to show the UI, and then we can see how to interact with it, because we need to send input events to ImGUI. So this should stop. No. Okay. So we start with ImGUI.new frame, and then we do whatever we want with this, and then yes. Okay, let's render. So in here, let's come in. Let's make a new function as we are used to by now, I hope. Okay, so just here, let's do func init ImGUI. And of course, all of this will probably honestly be abstracted away into nice class, because very soon I would like to start making a small game, just a small kind of demo, test everything out, test the abstractions we made, everything, make sure everything is going well. So we'll even have a window library, a window class, maybe something like this, which we can use, because right now we're still doing things kind of bare bones. All right. Let's do ImGUI v4. Yep, we have an init creates context. Yep. Font, so it says if we don't, we'll use a default font. Yep, sure, we'll go for it. And then we get let's have, I think we need this. So these here, and let's do IM context, and that's an ImGUI before dots. Wow. Why is this one? Oh, right. On context, right? That's a pointer. So I'm context list call right after load buffers is init ImGUI, and then we create the context, let's store it. Right, I am ctx equals this. Cool. Now let's see, what do we need to do with this? So we have our main, we have our run in the example, which we open twice. Let's keep that run. Let's see, we need probably the platform and the render, right? Both. So the render is potentially the more important one. It's a platform and the GL3 render. So the platform, it's just a bunch of SDL. So is there any ImGUI stuff? Yeah, there is. So ImGUI IO, sure. New SDL. Okay, just storing references. Okay, this is per frame. They're doing this. ImGUI set display size. And then, okay, they're passing it some events like where is the mouse, etc. So key mapping. So inputs, let's leave for later. Let's just get to display. These are all input stuff. And mouse position, set display size is this. Okay, accommodate. Yeah, we probably need this, but yeah, okay, so we need to give it delta time. Sure. Platform. Okay, so we probably want this. We just kind of start with what's there, try to get something to work, and then we can make it our own essentially. All right, let's go here. We have our display size. We have the imctx.getIO. ImGUI.gets current IO. Okay, current IO. Let's set display size, and then okay, ImGUI vec2, and then that's our width and height. So we're telling ImGUI. So ImGUI doesn't know anything. It's too low level. It leaves everything to us. It just sends us based on the information we give it, sends us something, some vertices to draw, and then we send it what's happening in our world, like kind of our game world. And with this, so timing is honestly something we need to do really bad, but for now, let's just do a hack. Bar time. So this is like the time since the game started. Time float 32 equals 0. Right, so we start at kind of 0. Then if we already have progressed a little bit, let's get this IMIO. IO is, so we'll get kind of context and object to work with. Communication struct for the active context, right? So that's our input output with ImGUI. So we tell the screen size, and then we say, hey, ImGUI, this is our delta time. And I would definitely discuss delta time on one of the extremes when we do the maybe next one where we do the timing. We just sit and discuss, okay, what do these times mean? What are we doing? Okay, so let's do the time. Is this okay? So that's the delta time. Now, if the time is 0, I think we won't have anything. So we need to give it some default stuff, because we don't want to send it 0. ImUI, ImIO. Okay. Then we just kind of increase the time. Let's make it, yeah, makes sense to have it a U. It's 64. Yeah. And we don't need this. Okay. So yeah, we're sending kind of timing information to ImGUI. Per second. Yeah. So I think the SDL performance counter is how much time since we started. Okay. So we have this. So we're sending it some important info it needs, but the rest I think is just inputs. We don't need that. We don't need that yet. Okay, so that's all the platform does. This is the main thing, I think. So they have an OpenGL struct, which implements a renderer. We'll probably also implement something similar where we have renderer, so we can support OpenGL, DirectX, Vulkan, something in the future. Okay, create device objects. Let's see where all the okay, is there IO dots? So in OpenGL, what did they do? They create device objects. Let's look at that. Let's kind of walk through all of this. Create device objects. There. Backup GL states. For us, we don't need to backup anything. Renderer. So they're setting up the shaders, compiling. Uniforms. We have done all of that. It's very nice. Okay, they have some VBOs, and then create fonts, and then they're setting them, restore. They're just generating. Okay, so I think this is the font for ImGUI, and we need also the shader. We look, they are providing us the shader here. So let's create that. Let's have an imgui.frag GLSL. Right, and let's also have a vertex shader, and now we can take this, just plug it in there. That's our vertex shader, and this is our frag shader. So very simple. It's very simple shaders. Some of them we have not covered yet, like the texture sampling, but it's relatively simple. It's not really hard. We just need to specify now the version. So let's go with the latest stuff. So right now, I think we need projection matrix. I'm not sure. Maybe not. We'll see. If we need to set it, we'll set it. At least to an identity matrix. So we just want to see the UI. And then what's being sent is a 2D position for ImGUI, where the vertices that make the windows and the text and so on. And then we have UVs and we have colors. Right? And then some of that is sent to the UV, and the color is sent to the fragment shader. The fragment shader samples the texture, looks up using the UV, and then yeah, applies the coloring. Okay. All right. So that's good. Now we need another shader then. Along with our simple shader, we need an ImGUI shader. All right, so we can do it in ImGUI. We can do that. So this thing, actually load shaders, we have function ImGUI shader. So let's copy all of this right here. The arrow is already there. ImGUI shader is this. So we create a new shader, we load, but this time we will do ImGUI.verts. Okay, say ImGUI vert shader and ImGUI frag shader. Frag, okay. And then we just set them and link. This is our verts. This is our fragment shader. There we go. So we have compiled. This should work, and it's using its own font, so we don't need to worry about that. And then we'll do a context here, and all right. So this is good. I think this one is covered. Let's continue with the render. So we get the IO, we get the font from ImGUI itself, right? And then once they have done this shader, the shader does need a few things we need to do. That's fine. And it also needs VBO. Might make sense to just have an ImGUI struct to hold all of its data. Let's do that. I always like to first start with putting everything in one file, like when doing a new feature, and then once we understand the requirements and how it works and so on, then we can move it out and abstract it and so on. Let's do ImGUI info. Maybe let's have this inside, and then this thing ImGUI info is ImGUI. This ImGUI info. There we go. So we have the context. ImGUI will need its own buffers in memory. So we'll need a VBO ID, right? That's uint32, I think. And what do you call it? Index VO ID for sure. Yeah, let's see as we go. We might need more. Yeah, so far they also have an element. Okay, VBO and index ID. Index for ID should be good for now. Okay, so now what we will do is ImGUI info. We make a new struct and we start filling it up. So the context is this. We need a buffer for the VAO and so on. Okay, so let's do that. So we'll do gl.gen buffers, and for now I'm doing it very bare bones. Then we'll use our buffers library later. So let's see. Okay, so we create this, then let's generate one for the VBO and generate one for the index buffer, and then we need to generate the VBO as well. Vertex arrays. VBO ID. Let's see if we need that. Don't they do this? Vertex. Oh, they do. They do. Oh, there it is. Okay. So they're doing it every frame. For them, they want to handle multiple GL contexts. For now, we're not interested, so we'll do it once. So, okay, let's go back. So new OpenGL, and this was render where we are not really there yet. We do these things. This for drawing the UI, they back up whatever the current state is on OpenGL. We don't need to do that. This is for the actual drawing, and then they set the uniforms, and here, okay, we can do some of these ones. So this is one we can do once. Binding buffers, setting attributes we'll do later. Uploading the data we'll do in a bit, and then they draw. So this is per frame. We need to do this, and then all of this is restore. Let's see what we can get, what we can do at the beginning. Doing all of this compilation, sure, done. Okay, they're storing the locations of stuff. That's fine. And generating these buffers. Restore, we don't need to restore. Okay, let's look into that now. So we'll have our image, and what are we doing with the image? We're uploading it to the shader. And then store. Okay, let's take this. So in it, we'll do these, and then load fonts, GPU, essentially. So let's get ImIO again, which is ImGUI dot correct ImIO, right? So we were asking it for the font. We don't need all this. This one. We're asking for the kind of font, which gives us texture, and then we say, okay, gen texture. I don't think we use this anywhere. Probably we'll bind it. So let's add this to thing. So text ID, and then so gl.gen textures, one texture, and let's bind it into text ID. So then this is done. Okay, then we bind. So we'll bind against our ImGUI info text ID, and then we're configuring it with minimum. Okay, filters, sure. Okay, and then finally we upload the data. Let's get all this here. Okay, so we have our image, then we say, I think we use it for this. Let's put it next to it. So we bind our texture, which we generated, we set some information on it, and then we say, okay, width, height, what's the 0, border is 0, format red, okay, and sign white, okay, and then we send the pixels. Okay, nothing too fancy, and then we store it, kind of like we tell ImGUI, like, here is where it is in memory, take it, at least for later on, so we can retrieve it. Okay, so text ID, I think that's that. Invalidate, okay. this is all the, I think, one-time setup that we need for ImGUI. So very soon, I hope we'll have something drawing on the screen. Now, this is init ImGUI, and then we have a render loop in a draw, right? And we probably want to draw it after everything else and before the swap, of course. So let's have draw UI. I draw UI. And then after we draw everything, so we kind of draw our game, draw the object that we have, and then we put the UI on top of it, right? Let's see. So for that, we'll need to do a bunch of work in the beginning, not all of this. We definitely need this. So display size 1 and 2 is essentially, we have this frame buffer size is different. I believe we can ask window for frame GL. I think a drawable size. That's the frame buffer. Yeah, in pixels for use with GL viewport, and this could be what we need when we resize the window, maybe. That's why our resize was weird. So let's get this frame buffer width and frame buffer height is here, and then if any of them is 0, I don't know why we have these brackets, those we return. So as they say, if it's scaled or something, if it's minimized or frame buffer is essentially nothing, we remove it, and then we scale draw data, scale clips. I think we need ImGUI first. So we need some ImGUI data, which is this thing. But I believe we can do this later on. ImGUI data. Okay, so let's see who calls the render to kind of understand this. It's the platform, so probably the run. So we do every frame, we do a new frame, new ImGUI frame, we do all the drawing, and then we do ImGUI render. Okay, so in our game logic, we have our inputs, we have our ImGUI stuff, then we can maybe draw some UI. So if we say if ImGUI.button click me, right? If so this will create a button on the default ImGUI window, and you can create multiple. And if that happens, for now, you can log click, right? And so, but we need to start. We need to tell ImGUI, hey, we're starting a new frame. We are starting a new frame, yeah. That platform. Yeah, so we do this, and then we tell, once this is set up, we tell ImGUI, okay, we are going to draw, be ready. And then at the very end, ImGUI.render. Between kind of new frame, finalizes, so as this says, finalizes the draw data. After this, you can do rendered draw data to retrieve the draw commands and execute them. Okay, so this is done. So in draw UI, we can assume that our draw data, that we can retrieve now draw data by doing ImGUI rendered draw data. So whatever you did between the last new frame and render, give it to us. Right? Give us this draw data, and then we can clip to the clip right. This is win width. Height. So this is all to handle kind of how big the screen is and whatnot. And let's just make sure everything's float 32. There we go. Okay. Back up the state, and then let's set up the stuff here that we need. Okay. So this is similar to, you know, we clear every time. We might do other things, set some modes, and then we say, oh, you want to draw as triangles every frame. So here ImGUI teams needs some specific things. So we're saying we have some blending, you know, potential for transparency or some effects. We have some depth, right? And scissor. Scissor is also an effect where you can kind of specify what you want to keep in this. So you can say only draw this box within the screen. Everything else just clip it. Right. Then we have fill mode. All right, so we have some settings. And then we're setting the viewport and in this case orthographic matrix, right? So it's not perspective. We don't want our UI to kind of go smaller and bigger. Maybe you do. You can do that, right? But in this case, we're not doing it. Right? So let's take this. So if you want to have 3D UI within the game, you would do it. You would do maybe perspective potentially, but if you're just doing it in one place, no need. If you just want to have it on top of it. So, I mean, we can use our thing. Let's just try with this now. We make like minimal changes until we get it to work, and then we can use our stuff. So this is display width, so window width. Window width. And here it's loads 32 window height. Then we have, right, our shader. So I am shader. ImGUI shader dot activate. Just what I. Then uniform. Here we can say set attribute location. But this is unbinding. Textures, unbinding the texture. That's weird. Okay, so here I am info. I am info the text ID. It's not unbinding, but setting the value to 1. Okay, oh, this is a location, right? So this is what location? Let's look at the shader. So this thing is setting attribute location texture. Okay, so where is texture here? We don't have that. That's weird. Oh, there we go. This one. So it's a uniform texture, and for this we have our nice little function, so we can get the location. ImShader.get attribute location, and what we want is texture, right? This is a uniform one. So we can get this. We're setting it to 0. Okay, and then we're setting the projection matrix, and the projection matrix is called. See what is it called? In this shader, ImGUI shader. It's projection matrix. Yes, okay. Sure thing. Let's do it. So for this we can use our set uniform at 4, or let's just do this. Let's get I'm shader get attribute location, and this is the name of the uniform. We're setting 1, no transpose, and setting the orthographic matrix as is. Okay, perfect. So we're setting some values. We're almost at the point where we're drawing. Let's take this. We don't need all of this, really. We don't need all of this because we already have a video. You can just bind it. So VOID, right? And then we can bind the VBO and vertex use vertex attribute array. Okay, so let's do our shader. ImShader.get attribute location, and the first one is, let's see these. It's called position. Okay, so this is our position. We don't need. Let's do it. Actually, we don't need the cast. All right. Let's take this. Then, so here we're just setting the different vertex inputs, right? As usual, we're setting. We have 3 of them. So we set position, UV, and color. So we're enabling everything. Can we use enable? Yeah, let's just use our functions in this case. So we want to enable position, UV, and color, right? This, so it's nice. This is one of the things that we can set at the very beginning. We don't need to do this every time. So potentially when we load the shader, I think, actually, let's do it in init ImGUI. So after we do all of this in ImGUI, shader attributes, let's just do it here for now. So we don't need to do this every time we draw things. And then, okay, so we now ask ImGUI, now we're getting to the section where we draw with ImGUI's help. So let's see. So this gives us the byte size to select fields and a vertex buffer of a draw list. Okay, so it gives us a bunch of outputs: entry, position, UV offset. So it gives us one big buffer, and it has all of these, right? Within the buffer, and it tells us where in the buffer everything is. So you say, okay, give us all that information, and then we'll use this information to fill the buffers with data. So attribute location of position, let's do it. ImShader dot get attribute location position. Get it for UV and get it for color, right? And then for the position, it's a float. So normalized stride is vertex size, which we again get, and then the offset. Cool. So we have offset for each, right? And then the total vertex size, which we know now, and yeah, that's it. Just the color here. Now these, both of them are vec2s, so we have 2 values, 2 floats, and this one is a vec4, RGB and A transparency, and this is unsigned byte. We have this, and then okay, index buffer layouts. So we have our vertex buffer and then our index buffer, which is the positions, if you guys remember, like we did when we loaded our buffers, right? So this gave us the indices of the triangles we have to do when we're loading, and then that had its own buffer. So we are getting this again from ImGUI. So ImGUI is that's why it's low level, but it's really nice because it gives you can do it in any way you want. It just gives you, here's the buffers, here's the raw data you need to draw things. So we take now the index buffer, and draw type. Okay, why is this? So unsigned short. So we're saying, hey, is it are the indices ints or unsigned? So what's the maximum number of essentially triangles we're going to get, or vertices that we have? Do we have more than unsigned short is up to 65,000 vertices, and then int is like 4 billion. So I think Unity, for example, you cannot load a mesh with more than 65,000 vertices, if I'm not mistaken, because they're storing this in the index buffer as short. So index size. So yeah, we don't know what ImGUI is using, so we have to kind of check depending on the size. If it's 4 bytes, so if it's 4 bytes, then we kind of have an unsigned int instead of a short. Okay, finally we get to the draw. Nice. We actually render now. So this is all set up. So we prepare the GL states. We have the viewport. And then let's see. We set the attributes for everything with the new data that we just got from ImGUI, which we get here. And then we start drawing. So from the draw data, there is something called command list to draw. So we get a bunch of things that we are asked to draw. So we have a vertex buffer. So we get one at a time. We get a list. Then we bind that buffer. So let's do, because for us they're all using the same VBO. We're always using the same VBO for everything. So we can move these up. And this VBO ID. And we can bind, let's see. Buffer, okay. So we can bind this. What other binds do we have? We can bind the element array buffer, which is our index buffer ID essentially. So we can bind both at the beginning. We don't need to bind every time. Then we fill them up with data. We fill them up with this vertex buffer. So we get the list of things to draw. We have the buffer, we fill it up, we fill the index buffer again as well. And then callback, we don't really use this now, but let's keep it. Yeah, let's keep this. I'm not sure what it's used for, but we'll set the texture. It's the normal thing, at least. We'll set the textures. We'll get the clip rect that want us to clip to, and then we'll scissor it. Right? That's why we were enabling scissoring at the top. The scissor test is because, let's say, if you have an ImGUI window and you are drawing outside, then we don't want to put things outside that window. We want to maintain the position. So we're going to do this, cut it using our frame buffer, not our window, but our frame buffer height and width, right? Then bind, clip, and then finally draw. This doesn't exist. Okay, so draw elements like the one we have up there, draw elements index, but here it's just that with an offset. So let's see, draw elements, base vertex. I think this already has, yeah, with the per element offset. So this function already has an offset. Maybe that's an old function that's no longer here. Okay, so mode count, and the type is a draw type, right? And then the indices and save pointer gl dot, let's do that. Indices, offsets, index size, and vertex offset. Yeah. So where's the vertex and then the indices to draw from the offset? I think this is it. If we missed anything, probably just not draw. But I see. Great. Compile. Well, one way to know. Let's see if we have anything drawing on screen. It'd be very cool if we did it without mistakes from the first time. A bunch of this should honestly be abstracted away. And this is probably what we'll do when we have our rendering system. Because right now we only have shaders and buffer management, still very low level. We don't have a way of saying draw this object, and then this object, has this internal state kind of so and so on. Okay, we have panic unsupported type int. Must be a slice or pointer to a singular scalar or the first element on two. So where is this happening? Probably in the last thing in Go 404. Yeah. Okay, so which one? Unsupported type int. Where are we doing it? Int. Is it this thing? Must be a slice or pointer to scalar value or the first element. Okay, so it's probably this thing or that. Yeah. Or this. What is this called? This is the base vertex. I think this is an offset, so we get a pointer offset. Takes a pointer offset and returns a compatible pointer. Rather than absolute, yeah. So this is an offset, not really the... Yeah, okay, let's try again. Let's do it. Drawing is still a lot of work to do. Even if we put all of these in buffers, so all of these would have to go into buffers, and we set the uniform, so on. We'd want a nicer way to cover this up more, but we're getting there, I think. But we don't have a way of nicely supporting interleaved buffers like this, where you have many things into one buffer. So that's why for now we have to do it in using pure OpenGL calls until we can get there. There's still a good amount of work to be done. Ooh, something's happening. Nice. So it's kind of disappearing, reappearing every time. Okay, and we don't see UI. So I think appearing, reappearing is because of the scissor potentially. So we will draw the background, then we draw the UI, but the UI kind of cuts, right? Has a scissor enabled. So let's here, let's disable this scissor test. We draw this, and then we draw the UI. But we should still have seen should have still seen the UI, even if that thing was flashing. I'm not sure. Clip rect, vertex offset. Do we also need to? I mean, didn't complain, but the base vertex. Do we need to do it as a pointer offset as well? I'm not sure. Oh, stable now. Oh, wow. Oh, I think there's a window here or something. It's not. It's not clearing. Maybe I'm not sure. Okay, so we still need to do something. All right, of course. So it expects a projection matrix. And all of these, are we setting all of that properly? But this is our projection matrix. We're setting it. The texture. Yeah, we're doing that. ImShader, attributes, doing all of this. Let's just confirm we have everything. So in, that's there, okay. Okay. Yeah, I think. So we are calling init ImGUI, I think. Yeah, alt here. And then every draw, we draw the UI at the end. And then we swap. which makes sense. And maybe we disable scissor test before we clear. Let's see, render draw data, and this here. Draw data. Okay. We don't need this at the top. We can just bring it closer where we use it. Okay, so we're binding the VBO. We're binding the index buffer. And at the very top, we're binding the VAO as well. Bind this. Oh, wait, we're also binding this one. Yeah. Okay, so we don't need to bind again. And then the index buffer. Let's see, and then we buffer both with different things every time. Okay. And then we get the texture ID. I'm just not sure what this texture is 0. Rely on combined texture sampler state. Let's look into this more. Set texture to. Okay, so bind. Let's see where do we bind textures. Yeah, we bind them right when we draw. Right. We store device objects, attribute, location, color, so on, position. Yeah, we're doing this. Bring all of this. Let's make sure that when we're knitting, we're doing okay textures, VBO, index buffer, and vertex service. Is there an attribute forgot to enable? Position, UV, color. Not really. That's all. I think this is. Well, let's see. Let's look at the render now, or the platform as well. So we do a new frame, and then we do an OpenGL new frame, right? Which we are doing, I think, here. New frame is essentially this kind of work, timing, and then a new frame, which is drawing. And at the very end is a render. And then we pre-render, and then we do all this magic. Render draw data, frame buffer size, and post-render. Okay. So where is this is the platform. So let's look at the calls that's making. Process events. Let's see. Pre-render. So what's our pre-render? Do they do anything special? What is our pre-render? Oh, thanks. Oh, okay. R.pre-render. So it's the renderer, clear color, and clear. Clear color buffer bit, and yeah, you're just setting the color and the color, and then clearing it. We already set the color from before, so we just have to clear it. That's fine. And then we pre-render and then we render. Right. So let's look at the display size. Display size, there we go. So window.getSize, so that's our window width and height, right? as so. So we're doing that correctly. And the frame buffer size, GL get drawable size with 10 height. Are we doing that correctly? GL get drawable size, yep, as a frame buffer. And then let's see. So here we need to kind of correct this, which is get GL FB width, FB height. Okay, just to make sure we're not overriding this. Okay. A new frame is all of this, nothing special, and post render just GL swaps. Seem to be doing this correctly at least. So, yeah, trying to see. Now, we can look into, and then the init. We need to make sure the init is correct, and the drawing is correct. I don't think game logic has any issues. Draw UI. Enable of this. Okay, viewport. Activate, set some uniforms. For the current, yep. Okay. So we're clearing. So we had to disable the scissor before. Did that, so that now that's correct. And and now that we are doing the frame buffer height, resizing window is actually working nicely. So it's staying centered. Yep, it's question all. And it was nice. So we have resizing properly fixed. Let's go. We got some help from this thing. So we don't need to do this every time we draw the UI. No need. We do it when we resize, and then let's confirm our ortho rejection. It's here. Display width, display height. Yeah, I mean, then we use the program. Yeah, texture and projection matrix. One false and 0 0 on the orthographic. Okay. Bind sampler, and then we have our video bind it, which we already generated before. Bind vertex array, bind the buffers, bind the VBO, and then do this, these which we enabled before. Okay. Vertex pointer with offsets, position, UV, color. I mean, these we just copied them. I think these are fine. And then we do the index buffer layout with this, and then we draw. Now to draw, we get. I'm not sure. Do we need to draw bind every time for every command? I don't think so. But I am not sure. But let's see. So you get the buffer information. We bind to the VBO anyway. We do. We did at the top. So I don't think we need it again. VBO, and we bind index buffer. Okay, so we bind this, we fill it up, right? And then the elements array buffer is the index buffer. Okay, and then index buffer is filled, vertex buffer is filled, and then for each command we bind texture to the texture ID, clip rect, let's see, FB, yeah, this is okay, this looks okay, and then this is odd. This looks good to me. Not sure where we messed up, maybe in the setup. Get uniform location texture, so we have 5 uniforms. Turn these VBO index buffer and let's see. Create font, and then creating is just this. Create texture and then bind it, set some settings, and then just use the image, upload it, and then store it, which we're doing again. Oops, like that. Yes, we're doing in it. Draw UI. ImGUI display size. Okay. New frame button. Okay. So we create the context. We generate a bunch of things. Texture, VBO, index. Go usually comes before. That's 3 buffers, 1 VBO. Then we bind texture. Bind the texture. Don't think we need to bind the VBO with it, do we? No, we don't. Okay. We bind it, we get the image, then we set the image. This looks good. This looks okay. All right. Then our render call is all of this. Let's make sure we clip correctly. We might have another float problem. Clip. No, we're doing this correct. So we do FB divided by this. Cool. Not sure if we have to do this in the beginning, maybe. But we never use the draw data, so I'm not sure. Backup. Enable a bunch of options. Set the viewport or the graphic. Set the uniform. And the matrix to that. Okay. So shader activate. I just confirm. Yep, let's use program. And then these get location texture and get location projection matrix. Yeah, texture and location matrix. All right. And then let's see, bind vertex, sorry, and then bind the buffer, the VBO. Okay, enable the attributes, which we did before. Do we have to enable after? Let's try. Enable, it shouldn't matter when. Maybe if we don't have data. Let's see. Actually, it's enabling before, so it's doesn't matter. Let's just see. Enabling, and then we do these. Let's run while we wait. You can read this. So enable each attribute, position UV color, position UV color, position UV color. That's good. Do it for. And then the index. So this is the only place I think might have a problem. Oh, still waiting on it. Okay. Unsigned short. This is for. Still don't see a window. That's odd. I am not sure. Row type. Are we using it? Yes, we are. Element count. Index size is this. Bind buffer. Let's do the binding exactly as they do. So we bind here and we bind here. So we get this, we get the data, we bind it, and let's bind here as well. But in one of them, we bind the array buffer. Then we have the VBO again. That's it. String draw, elements handle. Yeah, it's good. Base vertex with the per element offset, which is what we want. Triangles, element count, draw type, index offset, which in our case is pointer offset. Like that. Okay. Everything else looks good to me. Not sure if something is kind of. I mean, potentially the projection matrix is all odd. So if we look at GGLM and we look at the orthographic matrix, it takes a left, right, top, bottom. Right minus left, top, bottom, far clip, near clip. Nope, we still don't see anything. So let's let's see. So instead of this, let's use our own matrix. And okay, so let's use GGLM dot orthographic. So left is like, let's just make it huge. So left is like minus 10, 10. Top is 10, bottom is 10, near clip is 0.1, far clip is 20. That should give us this. And then we can do ImShader set uniform matrix 4 projection matrix. Then we can do this. that's it. Should be good. I'm not sure if this is the issue, but could be. Definitely could be. Definitely could. Video. Yes. Yeah. Looks okay. Come on. I think combination of ImGUI along with OpenGL made compilation really slow. Is not a good sign. We still don't see. My movement is cool, but the rest is not. Okay, what are we doing wrong? Deal vertex array. Blend. I mean, we can maybe just literally copy paste this and see. Because we did move a few things around here and there, but not much. Render draw data, post render. I'm going end. Yeah, process. See if there is any initialization code here. Let's run and the platform, and we look. Create. Yeah, there isn't much. Since ImGUI is created here, okay. Clipboard text interface. There. Okay, show another. Current context. Let's step through the code. Just see. Maybe start here. Then we can see, how it's going. There we go. Okay. What's happening? Did have started. Okay. There we go. Is it getting stuck somewhere up here? Maybe we should see. You can maybe even step from before, so the slowness could be coming from somewhere else. Anyway, let's go here. Video, VBO, index, and texture. So all of these should be some nice number. Okay, cool. And then get current context, bind texture. Here, get the font and text image 2D. Yeah, so we have some actual nice image. Then pixels is an array. Okay. ImGUI texture ID. There we go. And then we enable the attributes just to make sure. We might need to bind here. Enable attributes. Just confirm. enable vertex attribute, get attribute location. Because what is the bound shader for us to enable? And are we enabling it down here? Yeah, we are. It shouldn't matter really. Enable. Yeah, the shader definitely should be enabled here. That's at least one thing. Okay, set attributes. Okay, all of this we don't care about. Let's go into draw. Okay. Now our window should kind of, I won't see it here, but draw UI. Okay. All this is good. Activate set shader, orthographic. Here, yeah, we have an infinity. We have an infinity in the matrix. That's so good. Orthographic rejection matrix. Let's look into it. I kind of forgot actually how you set this. Right and left. This was 10, this was minus 10. Why was this infinity? There's our alpha 32. Left. Yeah, so 10. So this is like 20. Top, bottom. Ooh, top, bottom. It's wrong. Completely wrong. Top is 10. Bottom should be minus 10. This was canceling out and giving us 0. Okay, so this was definitely useful to step through. Minus 10, 10. Left, right, top, bottom, near, far. Yeah, it's good. Come on. See if we have UI now. Will we not? Come on, go. You can do it. No, not yet. Not just yet. Okay, I think at least we shouldn't have a. Oh wait, it wasn't saved. Let's stop here then. Put a breakpoint here and see what our orthographic matrix is like now. Now it should actually look good. And in the meantime, you can actually see orthographic. Okay. So this is the width of the screen. Okay. So we actually need the full thing from 0 till this, because otherwise it is too small, which makes sense. Okay, so yeah, now we don't have infinities going crazy everywhere, but let's see. VO is good, VO is there, and we have data coming back. We have things enable and set the data. Okay, vertex offset for UV position call. Okay. And then the index size is 2, so it's a short. Perfect. And draw data. Okay. Flipped. And then, all right, so we bind the VBO. And then the vertex buffer size. Okay. Then we do the index buffer and then exactly. Just one. Yeah, it's still, that makes sense. So we need to do 0 left and right coordinates of the first, bottom and top. Okay, so left is 0, right is win width, and then left and right, bottom and top. Okay, so bottom is 0, here it's win heights. Specify the bottom parts, top part. Yeah, so top, left, right, top, bottom. All right, 0, and then let's see. If this works, then we'll have a really nice UI system going on. I think we're very, very close to doing that. And then the only thing that remains is for us to pass inputs, which should be simpler. Shouldn't be as complex. But that's why also, really quickly, I would like us to go and start working on abstracting all these drawing things, like all the rendering system out. And that's probably one of the biggest parts of the engine, is just the rendering system. Yeah. Still, yeah. And oh, the viewport is not being set correctly. Wow, this is not good. The viewport is not being set correctly. Where's the viewport? Handle inputs. Why are you not setting it? Setting it to MQI. We're setting it here. Maybe it's not having enough time to draw. So, I mean, maybe we'll do this when we're drawing the UI. Where is this? So, here, inside the viewports. And what else? Yeah, we should also check again that these new values are giving us a correct orthographic matrix. But aside from this, should be good, honestly. And another thing is enable attributes should be after binding a shader. So we activate, we can deactivate here. I choose program, yes. Okay, now if we resize, we should, yep, it's correct. So now resizing is all well and good. Perfect. Okay, nice. Now, what do we have? Window resized, window viewport. It's really odd. I was hoping we'd get to inputs today, but seems not. But at the very least, I would like to get us to finish drawing these things. It could be this thing, honestly. Let's see. Let's just continue with this thing. So we're saying that we draw, we bind. Yeah, they're generating every frame, which you might try to do just to get it to work, and then we can move things around. Once you just do that, let's take this. Well, this we already have. Rainbow for display size. The cuts. And we might also maybe need this at the top. Just try. But otherwise, this maybe if this is to work, let's take anything that's unique to us. Or sorry, like we changed. Yeah, so all of this, all the generation, binding, enable, and then it's really weird. We literally copy pasted this. We're probably missing something very small, and just because of that, it's blowing up. It's not drawing. Why are you not drawing? Let's see. Okay. Get size. Set display size. Okay. And then total time. Okay. We're doing this. We're doing this. We're not doing. We don't need. And swap. Process events. Init video. Oh, do we have a stencil buffer set and depth? Maybe we don't. Maybe that's the issue. Let's go into init's OpenGL. Oh, wow. Maybe that's the. I'd be crazy. That's the depth. So we're using 8 RGB, right? So 888. That's 24. Then stencil size. Okay. Maybe that would be something. But the rest looks good. Okay, let's just make sure some of these fundamentals we actually have. Because it does rely on that essentially. Okay. This guy doesn't do much. Just calls process, new frame, new. Then this thing creates a context, gets the current, passes the context here just to be stored, and then does OpenGL, gets a renderer and runs. It's like glue. Oh, still not enough. Oh no. Oh, okay. But at least we have these now. So like take one more look at the renderer. Create window. And this is the renderer, no, that's the platform. Create context, swap, dispose, should so. Okay. Here we're doing set size, okay. Now in OpenGL, so font texture, ID, a shader, okay, vertex, yeah, sure. Texture, projection matrix, position, UV color, and then just the VBO and an index buffer, okay. And then we have OpenGL. Set backend flags rendered has vertex awesome. Do we need this? We didn't do this. This is ImGUI stuff. We completely missed this. This might be it. You never know. We can hope. Let's take this boy up. see if we can get UI today. All right. Backend flags rendered as vertex offsets. Oh, get backend flag. These are the default current. Okay. I mean, maybe not, but it's one thing that we're different in. So I want to make sure that we're really following everything they're doing for a start, and then once we have it working and understand what's going on, we can start playing around and abstracting and whatnot. Okay. Everything from here down, we copy pasted. We made very tiny changes, so it should. Don't expect it to be an issue. This is an offset, but yeah. No. Not yet. Let's see what else. What else have we missed? In ImGUI. So let's do IO. Is this called IO? Yeah. IO dots. So what do we have in IO dots? That's it. It's only 4 places. That's it. Font texture, texture ID. Font texture is texture. Yeah, just gen textures. Nothing special. All right. Let's see what we have in ImGUI dots. ImGUI IO. Okay. Set the thing. Get the draw data. Set the vertex buffer, index buffer. Oh, that's it. There isn't much happening. Okay, look at this. IO dot. The IO dot. Yes, there is. Okay, new frame, set display size. For window resizing. Let's confirm we do this every time. So I think we're doing it here. No, wrong game. Set display size. Yeah. So we're doing it here. Platform ImGUI frequency, and then time starting at 0, and then we set it every time, every frame, and that's just fun stuff. Okay, look at ImGUI here. Yeah, in a window called debug. Sure, you don't mind. You want to show another window and set next window, demo window. Is there anything else we call? Any command from this point until render or end frame. ImGUI show demo window. Okay, open. Let's say see if we see anything. I mean, if the render is broken, it doesn't matter. It won't help us, but we'll see. I guess we do want to see as many things as we can. We need to test out that any code that we have here actually works. All this rendering stuff. IM shader, and then position UV curve. We need to check our spelling as well. UV Rejection Matrix. Yep. Position. Looks okay. Other window, no. We don't see. We can move. We don't see anything else. Texture. Okay. One question I have is, which I still don't understand, is why are they binding? Oh, units. Oh man, I think this is it. We should bind. This is basically this, I think. Oh wow. It can actually be this. So attributes. Okay, this is a location. This is a bind. Where are we binding to? What is 0? 0 might not be the ID that we have. So this could be completely broken. But then sampler is, I think, the texture. I think so. I'm not sure. So the sampler, where is this thing? There we go. It's the texture. Interesting. That was the only place. And then what's the texture? I don't know why this is 0. So we need to see, but let's try. The location might not be even 0 in our case, and so it doesn't make any sense for us to bind to it. We need to get, okay, so we bind the sampler and then all of this follows, right? Otherwise none of this would work. But we do need to know, okay, this is GL bind, so maybe this is the program ImShader, and then this is the texture location. Yeah, so let's just confirm. Let's see, and while we look up the docs, we can take this uint, and then here the one we have is shader ID. So we can bind sampler. No, it's okay. Index of the texture unit to which to bind the sampler to. I'm not sure. Let's look at the texture section. Textures. So bind gen texture, bind texture, which we do, gel texture 2D. Okay, so where is our bind texture? There we go. Now we have the bind ID. Sure. I mean, that's okay. It's all well and good. And then so gen textures. We have some maybe texture parameters, text params, then store and text image 2D. This thing. Right. Geored, width and height. Okay. And then the data. So you bind the texture. Okay. The sampler. This thing that's required. Bind sampler. generates find the texture. So there is the sampler something on the GPU, then combine. And do we not find the texture again? We do here. Okay. Set texture. Just to make sure that's why don't we get our own texture which we saw, just to make sure, because we already stored it in ImGUI info text ID and we know this is correct. We can do that and then text texture ID, although we are storing it, but you know, just to be safe. Okay. Then do this. Units. Textures to samples. Let's look into this. Must be uniforms or function parameters. Yeah, sure. Let's do. Okay, bind texture. Array samplers. You may use equivalents. Okay, so I have some images. Activate the program for texture units. Okay, so I think it's on the GPU. Bind sampler 0. I think this was correct, because we set the texture to 0 here. Right, get attributes. Actually, this might be wrong as well. That's another thing. Where's the texture? It's a uniform. It's an attribute. It's a uniform. Get uniform location. Right. Shader program. GF get uniform location. Yeah. Yep. All right. So this was one error. Yeah. We were using attribute, but it's not an attribute. It's a uniform. Texture is a uniform. Right. Let's do this. Get uniform location. Yeah. This thing. Oh, no, wait. Get uniform location. Program is ImShader ID, and the name is this thing, and then we set it to 0. Yeah, now this should be correct. And then the sampler, since we set, I think, this to 0, then we bind the sampler as they're doing here. So we have the images, we set them, the image location, which is a uniform. Right, get uniform location, and then we set it to some sampler, some texture unit, and then we can bind the sampler here like this. 0 for whatever, for each, or 2 or 4, depending on what we're using. This looks good. This might be actually it. Okay, yeah. So we learned something new today. And be careful about uniform and attribute locations, not mixing them up, because this just happens. And we need to just also confirm for the projection matrix, set uniform. Let's look, where do we use projection matrix? Set uniform. Okay, so set uniform should act correctly, as long as we're not using it with raw OpenGL calls. Oh no, we still don't have that. But it's yet another bug that we have fixed. Let's see. Set uniform projection matrix, get uniform location. So let's see, where do we use the texture? Right, that's one thing we should know. Texture ID, this is fine. Gen texture, bind texture. Where is the, okay, oops. Bind texture. Yeah, to the font texture, which is the ID, essentially. Font texture is just the text ID. Okay, that's fine. And this is good. Then text parameters, and then this. View, and we bind all of these. I think we should also, since we're not deleting the view at the end of each frame, we should unbind it just to avoid any issues. So at the beginning, we bind, where is this? Bind the vertex array. So at the end, we should also unbind this and unbind, actually unbind all of them. Should unbind this thing and unbind the element array. So bind the VO, unbind the VBO, and then take one, just to make sure we reset the state correctly. Okay. Yeah, again, the worst case, let's take this and have it in and work our way backwards, essentially, to get something to draw on the screen. So let's do func draw UI2. It's essentially the same, but yeah, so we don't need all the backup stuff. It's way too much. Still not working correctly. Let's see. So in our draw, we already did this part. It's done. What's the issue? Oh, we're doing this. Okay, perfect. Now we want the draw data. We have it here, and that's FB divided by the window size. And then we enable a bunch of settings needed by ImGUI. We set the viewports, which we have from above. We'll use for now their own orthographic projection, just in case there's a bug in the orthographic projection library. Load 32. Okay, perfect. Oh, what happened? Okay. This thing is our shader ID. So I am shader.id, and by the way, we need to confirm also that we're loading the shader correctly. So load shaders. I am shader is a new shader program. I am GUI with verts. the GL cell, the trivial GL cell, and then I'm shader. Okay. This is okay. So you have the shaders. Good. Texture location. Okay. So we're not risking anything. Let's go grab this. Right. And honestly, just plug it in. Well, we do have this thing stored, but like whatever. Let's play it safe. And then the projection matrix location, which is this thing. Right, and then again we give them the ID of the shader. Great. And then oops. Okay. The bind sampler. Great. And the projection, then we have the VBO ID. The location. Okay, we need this. No, not this one. There. This. We need the location position. Okay. Get attribute location. So we have a bunch. We have these three. This again. Grab it. Grab this. UVs. Go ahead. And then finally the color, right? Color. All of these as a shader ID. Awesome. So now this is good. Color position UV. VBO handle again. The VBO ID. Index buffer is our index buffer ID. And then finally, and this could be the source. The problems that we have is, well, draw elements, base vertex. Right, this one. Indices and type, but there is no. Okay, so we have. So that's the original one. Let's just copy it. Commit it out. Because we don't have this function, but we do have base vertex, and the comment does say with a per element offset. The only difference is this thing, we're going to use gl dot pointer offset. Everything else is the same. So this didn't take long, but we copy pasted all of this out correctly. So then the only difference now, sorry, not the old raw UI. Here we're going to do raw UI 2. Let's see if we get UI. Let's see. Well, the only other thing then that we have different from the example code is this thing, is the init, because they do some of this every single frame. So if it still doesn't work, then honestly I would also do this every frame, just to see something. Come on, you can open up. Ooh. We have probably some null pointer or something. Let's look. Let's debug. Let's see. Come on, VS Code. I mean, it's probably not here. It's probably in row 2. That's the only new thing we have. Get drawable size. Yeah. Wait, is it running yet? What's up? Could not find source. What is wrong with you? Oh, okay. So far it's good. So last time we ran, it crashed. All of these should be fine. Okay. As expected, let's go into the draw. Step in. Step into this, and let's see. This should be fine. Rendered. Okay, and we should have reasonable. Cool. Yeah, in this case, you know, these things match. Enable all of these. Okay, adjust the viewport. Sure. And then, all right. What's our ID? So we have these, okay. And this thing. So far, so good. Oh, where did we? Oh, okay, there it is. That's the. You'll be using this. We have our own. Our own VO, so we should probably use that. Are we deleting the VO? I mean, for now, just try. One thing is the VO. Let's delete this VO ID. Get rid of this breakpoint. Let's see. One interesting topic after rendering is honestly physics. And I really want to get physics, you know, the famous NVIDIA library working. So I haven't found anything there, and any other thing that people has done is usually like 2D physics or something like that. But if you really want high quality, high performance stuff, you want to use something like physics. But it doesn't seem they provide bindings for Go by default, so might be one thing for us to wrap and but they do provide an SDK, and I think can build it into DLLs and whatnot. So we'll probably look into that in the future. That'd be very interesting. Okay, what's our VAO? Okay, that's a proper ID. VBO, proper ID. Array buffer. Okay, position. These are good. Okay, are these sensible numbers? Yes, they are. Perfect. Index buffer layouts. That's oof. Is this correct? That doesn't. Oh, okay. Yeah, that's not the size. Yeah, that's just a short. Throw type. Index size. Okay. We bind this, we buffer the data, we bind the texture. Okay, so we don't have this texture because I think we commented it out there in it. So there, then it will crash, obviously. Yeah. So in it, I'm doing. Wait, we're doing it. That's so odd. Then it is as we expected, I guess. This last thing, it's actually that's the one that we don't have. And there is something extremely weird about this. So this is an offset, and maybe this is an offset as well. No, right. Let's look into gel triangles, blah, blah, blah. Okay. Number of elements, type, sure. A pointer to the location where the indices are stored, a constant to be added. Index offsets. So these are our indices, but how are we passing the actual indices? Is it by binding them before? I guess. Just like here, we don't pass them directly. We just say, here you go. So I assume this is good. Then we clip it. And I wonder why last time before it didn't crash when it reached here, but now it's crashing. It's very, very interesting. Index size. Row type. Element count. Base vertex. Is any of this going out? Doesn't seem to be. Interesting. It's we can't even say it's the VO because or anything with that because it's failing on the first row call. Generate gen vertex arrays is used. Yeah. Yeah. Okay. Let's see. Is there anyone who commented on this? I'll be interested to see. Let's see. Blackness. GUI. And yeah, backend. Okay. Pro UI, get the dropbles. Pro directs. I really wonder why it wasn't crashing before and now it's crashing. That's really odd. We bind this, we bind the VOs. So all these things is... Okay, are we defining any variables here? No. Just... Yeah, it's just here. Okay, let's see if anyone asked about this. It's not in the same report. to avoid the use with offset. So it seems even if I'm using the latest one, this doesn't have. Okay, index. Interesting. So this is the original way, since we don't have this binding. Interesting. Index buffer offset. So, but we do have base vertex. I'm not sure if it's the same base vertex. Just okay. Glow draw elements base vertex. Let's see. I mean, we're doing this, then this thing is they're doing this right after. Right, draw elements. But where is this defined? Index buffer offsets. Index buffer size, index buffer. Yes. Index offset. Yeah, I assume it's this one. Vertex offset, index offset. Da, 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 da. Maybe it's defined here. Index buffer offset and end pointer. Okay. I don't know. Let's see. Because they're using Go, so are they using the same thing? Well, they're using GLFW. But where are they getting their GLFW is like STL should be interesting. Okay. Let's see if we get a window or we crash. We crash. Unfortunately. Exit status, let's look this up. Sorry, today's stream is surprisingly long. We'll have to cut this up on YouTube, I think. Open GL. Yeah, so some invalid memory. Probably going out of bounds. Probably going out of bounds somewhere. Okay. This. This doesn't make sense. This one makes more sense. Any questions so far? Guys, all okay? If you have anything, you're confused about, please feel free to ask. Hey, Mr. Mugami. What's up? Welcome to the stream. We are trying to do ImGUI, some UI into the engine. But as you can see, we're trying to follow the example, but it's not exactly working our way so far. But we're fighting. Come on, can you run? So now we should get back to the just white screen. Well, let's go back to draw one. Doesn't seem there is. It's actually, our thing was better than this. It was just drawing correctly. Let's see. Now we should see a white screen. Or like our object floating around. Okay, can move. We see projection. We don't see UI though, even if we. Yeah, viewport is working correctly. Okay. Hmm. Let's see that. Let's make sure we understand every single line here. These are just options. I don't really mind. If we deactivate before drawing the things, and then reactivate just before we do the UI, which should be okay. Then let's use this projection matrix. Dun, dun, dun. So it'd be crazy if all of this is just because of the projection matrix. No way, but one way to know, I guess. So here, and so we're copying their exact code that they're using in the example, their exact matrix. And maybe this is something for us, but otherwise, we're doing this function. So here's this projection matrix, a uniform location, bind sampler, okay, which we use, number 0 is what we use, bind the vertex. So we are building a game engine in Golang from scratch. That's what we're doing, and we're trying to make like a full-blown 3D game engine and live stream the whole thing. Oh, we did. It was a real matrix. 3 hours of work have paid off, guys and girls. It doesn't have inputs. It doesn't click because we didn't send it inputs, but hey, it scales correctly. And our object still receives inputs behind, so you can see how it's transparent. And this is amazing. Yeah, the work paid off, definitely. So all of this was a broken, well, we did have bugs, but it was broken projection matrix. We'd have to fix them. Yeah, so continuing my answer, it's we're doing the UI. So we had a few to-dos moving forward, and today we did a resizable window. We had camera moving, so that's what you see moving in the background. But now we're trying to get ImGUI integration. And if you don't know ImGUI, it's a crazy good library, immediate mode UI GUI library written in C++. But there are these good guys who essentially made it for Golang. This one, ImGUI Go from Inky Blackness. And it just lets you very easily have all these kind of windows and have all these controls and buttons in place. And we're trying to integrate it into the engine, at least like have an initial setup working by following their example, which you can see takes a bit of code. But now we actually have it not fully running, but we have it drawing at least. Okay. So yeah, that's really good. So I think we can get rid of this now. bye. And we can disable the the demo window. So we only have one UI thing called click me, and if we click it, it should say okay. If we run this, we should see this. I don't know. Aside from this, yeah, this is looking good. So we do need to kind of see. I would be interested in seeing what GGLM produces. Projection mat. Oh, okay. So that was my mistake. Potentially, it's not the math that was wrong. Name of the matrix was wrong. This is projection MTX, and I wrote projection math. All right, that's crazy. Okay, you see only click me, but it doesn't actually click. We'll do that later, but let's try to use UGLM to use these nice functions. But we write the correct names now, and then we bind the sample. Let's see. Declared but not used. What do you mean? Oh, okay. That's one of the things that we'll be looking maybe in later streams I've been working on. So I already did the math library. I think it's pretty complete as far as functionality goes. Is asset import. So we did write a small OBJ file loader. You can see it's tiny. OBJs are really nice and simple, but they're not really powerful. They don't have a ton of functionality. And the best library that I really found for doing this is called asset imports. Open asset imports library. This one. It's crazy good. It can import like 40 plus 3D file format and can do post-processing and optimization, so on. I didn't find anything close to it in Golang. So I guess we have to unroll it. Okay, so the projection matrix is definitely broken. The math is broken because we lost it again. So we have to win width, win heights. Bottom. That's the bottom, and the top is the window height. And then the width. What is our thing doing? So right minus left. So this is right, okay. Right minus left, which gives us just the window width, correct? And then window height is top minus bottom. So we should flip these. Because, no, actually that's going to top minus bottom. Yeah, top minus bottom, and we just... Oh, okay, so that's the mistake in the thing. It seems this should be negated. There should be a minus here. But otherwise, it's good. So we can try this. UGLM transform minus, and the rest I think is okay. I hope. Let's push. Fix what do you call it? Fix ortho. Alright, let's push it and then target. Where are we now? 2.5. Yeah, the rest we can actually compare these two. Go get come on, give me the latest version. Wow, it's not. Oh, I have to go on nMage. Nope, still not getting the latest version. So let's force it like going here and doing. That's weird sometimes. It's really odd. Yeah, sure. Let's see. Come on. But yeah, so this is good, and great, we got the latest one. Now let's run, and hopefully we will now, using our own code, see projection matrix, see the UI. Now about the asset import, I wanted something like this, instead of maybe only implementing one format or something, and something that's actually powerful. So when we build an editor, we can have nice features like a real engine or Unity or something. And so I decided that this for now, like, I didn't find bindings for this for Go, but there are bindings for everything under the sun. All of these languages have bindings, but not Go, which is why I was saying, it seems Go is a bit behind in the game engine race. We still don't see the UI. That's fine. We can use the other projection matrix for now. But we're behind. So I started working on, and it's actually kind of working. It's functional. I wouldn't say it's good. It's functional. Using auto-generated bindings. It's called asset import Go, I think. Yeah, it's this thing. If you guys want to have a look, it's very early. It's still there's a lot to do, but we are using this thing called Swig, which helps us. It's a big file. It helps us auto-generate things. So it auto-generates kind of wrappers for Go, and it's huge. It's like 11,000 lines or something. It's huge. It's 13,000 lines just to wrap all the functionality and whatnot in it. And I mean, 1,500 is just as comment, but yeah. So we might use this going forward. Yeah, even Vulkan, I have seen, but I don't know how good they are. Vulkan Go, I have seen it, but I don't know how good it is especially compared to OpenGL. OpenGL bindings are really good and complete and auto-updated, etc., to match the spec. This, I know. April 2nd, it seems updated. Yeah, maybe it works. Maybe it's actually good. I haven't tried it, but yeah, Vulkan is a project by itself. It's huge. It's really huge. Okay, so definitely a to do that we have at the very top is fix ortho function, which I'll do later. But yeah, guys, I think have a good day now, and we'll see you next week. Right? I'll just push this. So today is day 6. Let me revert to a working state first. Let's put this back so we actually have UI. This and this thing is ortho projection 0, 0. Right? Oh. Wait, we're resetting it twice. No, it doesn't matter. Yeah, this is good. Okay, let's run and confirm, and then we push, and you guys get it. Thank you, Danny Game, for coming. Hope you enjoyed. We'll pick up next time. We'll have, I think, inputs on the UI, and we should be able to drag it and whatnot. I don't know about docking. I think docking is a new feature where you can actually like dock windows like in Visual Studio. That would be crazy. Like if we can have all of this in the engine already, and then we can start making all kinds of things with it. But I think we can start working towards. I don't see why, with the performance of Go and so on, and the concurrency especially even, why we can't have good game engines. But it does it really seems that there hasn't been work done so far. No asset imports, barely anything. Even FBX, I didn't find a good FBX library to import in Golang. It's crazy. So it's kind of weird. Okay, we have the. So we have a lot of work ahead of us. There are no physics bindings. There's almost nothing. So it's oops. It's also good for us because we'll have a lot to do. Let's git add, git push, day 6. So just wait. Let's say day 6. ImGUI rendering. So we made the movement MVP matrix plus movement plus ImGUI rendering, but no events yet. All right, guys. See you, everyone. Thank you for coming, and see you next week. Have a good one.